Hello, hi. My name is Devanthran Perumal, and my matrix number is CE210201. And I'm here to present a slide which contains the Bachelor of Degree Project 2 entitled Cigarette Smoking Detection Using Convolutional Neural Network. And for the introduction, I would like to give a basic intro regarding my project. The first is cigarette smoking remains still can be consumed as a major health issue which has been happening around the worldwide, and it contributes millions of deaths annually. As we all can know, the amount of people that's causing by the cigarette smoking is eventually increasing year by year. So not only smokers who are affecting by the smoking activity, the second-hand smokers will also be affected, especially in public spaces. So in a deeper level, Malaysia, we also enforce so many laws, uh, which has been tightened, as you guys can see, has been stated in the list where September 23, 2004, Malaysia introduced the control of tobacco product regulations under the Food Act 1983. They have implemented a law where they ban smoking in 90 public areas, and furthermore, they have strictened up the law by in June 1, 2010, where they banned smoking activity in a workplaces that contains air conditioner, and the person who are unable or not following the law will be fined up to 10,000, or also even 2 years imprisonment. To tighten up even more, in January 1st, 2009, they have implemented a law where eatery places or restaurants will be a place, as a smoking restricted place, including a 3-meter buffer zone. In October 1st, 2024, the Control of Smoking Products for Public Health Act 2024, they have came into an act where they declared 28 areas as being a non-smoking place, including pubs, discos, and laundries. Recently, this year, January 1st, they have strictened the enforcement even tighter, where individual who still recklessly doing the smoking activity will be fined up to 5,000, especially the tighten up zones like laundries, workplaces, buildings, pubs, and nightclubs. Apart from that, in technology era nowadays, computer vision and AI often a new opportunity for automated monitoring. So deep learning, particularly the CNN, which have been implemented in this project, has proven effective in a image and a video recognition task. So for that, we have introduced a method where smoking activity can be detected through the CNN. So for the problem statement, we have stated three. The first one is public smoking violates regulation and poses health risks, where it has been stated in introduction as well. Manual monitoring is inefficient in large or dynamic environments, where we as a people, we can monitor people who are smoking in between in our eyes, but it will be error prone. We cannot observe in a wider area language. So for that, implementing a smoking cigarette detection will be a good idea for this kind of automated detection. So the third one is need for automated real-time and scalable detection system. And for the objective, to consider all these problem statement, we have three objectives have been stated and clarified. The first one is to able to detect a cigarette smoking using YOLO V8 CNN model. So the deep learning model that we have used is YOLO. You only live, uh, you only look once, version 8. And the second one is to evaluate detection performance using mean average precision, and also recall. And the third one is the main motive objective was to develop a real-time detection interface in terms of smoking detection. And how we want to implement this system. So first we need a data set. The data set of contains smoking images. So where we can find. So we found all the data sets and collected through RoboFlow. In RoboFlow, we have annotated the data sets, each images with three type of classes. One is cigarette, one is face, and another one is smoking. So after that, the datasets will also be pre-processed, like brightnessing up the images, resizing, flipping, uh, and also rotating in order to improve the model's generalization. And after we get all the data sets, the next step we will like to continue is the model training, which I did in Google Colab. So YOLO V8 nano model was used to annotate the dataset using GPU. Why not CPU rather than GPU? Because CPU will take more time of execution compared to the GPU. And the training configuration was 50 emojis. Batch size was 16, and the evaluation matrix was given by the Google Colab after all the training was done. And after we got a model in PT format, so what we have to do, we have to deploy the model in a interface, which I conducted in PyCharm Streamlit. So Streamlit was user interaction for the real-time detection. It supports both video uploads and live webcam detection. So it will display in boundary boxes where if a person is smoking means the cigarette will be classified as a cigarette, and the person who are smoking will be classified as a face. So not only that, it will give a real-time alert also by through Telegram, where it sends a real-time alert in uh, in attached with the image of person smoking, the location, the date, and the time. Apart from that, we also can generate a PDF report where authorized person can use that as an evidence and give as a summon for the person who was smoking. So the architecture flowchart, this is the flowchart. How does the Streamlit website conducted? First, if we launch app, it will be have a two access role-based access. One will be a viewer, one will be the admin. So if like we have logged in as a admin means, it will go to the main dashboard where it will be two options where user can upload a video or stock footage, or turn on the webcam to detect in real time. If the person start webcam means it will generate the real-time detection. And if the real-time detection detected a person is smoking in front of the camera means it will automatically send a notification through Telegram to the authorized person, where we have created a Telegram bot including the persons who are authorized for detecting the smoking degrade. And then the person can be if the user login as an admin means they have the access to generate the PDF report and also download the CSV file who all have been logged in through this website and interface. Apart from that, if the person is choose to upload a stock video, they can upload a video or random video or stock footage video where a person contains or smoking activity. It will detect and display an output if there's smoking activity in circles. If not, we can log out, then end. And the tools and technologies that has been used for this project is, in terms of programming, Python was used, OpenCV, and then NumPy. Frameworks that have been used is YOLO V8, Ultralytics, and Streamlit. Two main platforms that have been used is Google Colab in terms of to train the model, and PyCharm is used for coding, debugging, deploying the Streamlit detection. APIs that have been used is Telegram. One is for for real-time alerting. And Report Lab was used to generate the PDF format. RoboFlow, which is a platform that we annotate and pre-process and gather all the data sets. And the data set preparation, how does it done is the source was in RoboFlow. So in figure 1.2, it will show the, as you guys can see, it shows the data sets that contain smoking activity, and there is a boundary boxes over there. And in figure 1.3, it shows the RoboFlow annotation interface, where it classifies three types of annotated, whereas one is smoke, another one is cigarette, and the green color one shows the smoking. And this one shows the pre-processing size, where all the datasets was resized and its brightness was updated, and flip and rotation also was implemented in for all the datasets. And then the datasets were split into three different classification. One was for the training, another one was for validation, and the last part, which will be the testing part. For the training dataset, it's split into 83%, and for the validation, it's split into 12%. And for the last part, in order to testing, it was split into 6%. And for the model training, which was conducted in Google Colab, figure 1.6, as you guys can see, it stated the YOLO V8, the nano model version initialization. And the figure 1.7 shows the training output. And these are the coding and the attachment that have been implemented in Google Colab. And in order to calculate the evaluation matrices, these are the output graphs that the Google Colab have given us in terms of precision curve, in terms of recall curve, and in terms of F1 score curve, and also in terms of PR curve. So the values that we have gained is in terms of accuracy, we got 95.36%, precision in 93.73%, recall 90.36%, and also the F1 score 91.86%. So these results will show has been shown a good result in terms of detecting the smoking activity in a larger scale. So for the real-time detection, figure 1.12 shows the real-time webcam detection where we implemented in Streamlit, and figure 1.13 shows the real-time video file detection where users can upload a stock video or footage in there and will detect given boundary boxes in three types of classifications that we have been stated. And for the alert and reporting system, the first figure will shows the Telegram notification where the authorized person can get the real-time notification if a smoking activity or incident can happen. And figure 1.14 shows the PDF report where where admin can download the PDF report and attach that as an evidence to give to the smoking persons who are smoking or get caught by the authorized person. So this project, in terms of strength, limitation, future enhancements, the fans is it's a real-time fast detection, and we have used a lightweight model where YOLO V8, the nano version. In terms of alerting and real-time system, the system was implemented to give a real-time alert through Telegram and also a PDF lab report. For limitation, the accuracy might be low if the image or the real-time detection was occurs in a low light intensity. Small objects like cigarettes sometimes may be misclassified as a cigarette. So in that term, we can improve them by the future enhancement where we can train the model by using a lot of data set that contains low light smoking activity. Another suggestion in future enhancement will be the integrate a smoker ID with the face recognition. For an example, if a student means, we can identify a student's face by substituting their face classification to their particular name, and expand the data set in variety of improvement, develop or mobile or embedded platform. Also, we can add an audio in order to alert that system. So last but not least, I would like to conclude my project. And this project was successfully implemented using YOLO V8 for smoking detection. And it also achieved a high accuracy in real-time performance. And it is also ready to deploy in surveillance and also for public enforcement in order to prevent smoking activity occurs in a real time. So it will also help public to reduce the health issues that has been occurring, which I've been stated in introduction as well. Thank you. Hi, so this is the interface that have been developed using Streamlit. So the first interface that you can see is login activity, where we can log in as a two user. One is admin and another one is a viewer. Let's say we log in as an admin here. I've set a password for each user. One is for admin, which is the admin pass. Another one is for the viewer, which will be the admin pass. So if you log in as admin means it will log in. It will state it as a login in as admin. So in here we have two options where we can upload a video or stock footage, as I've been stated. Another one is a webcam detection, where we can detect the cigarette smoking detection in real time. So let's say we click a webcam detection, start a webcam. It will take several moments to turn on the laptop's webcam. Other than that, we can see the two type of options, where especially for the admin users, where they can download the detection log and also the PDF report. Let's say we start a webcam, and if let's say a person smoking means it automatically detects, and there will be a notification sent through a telegram. So for the real-time alert, as you guys can see, here's the telegram bot that has been created, and it will be sending the image as an evidence, and also the notification where declared as a smoking detected, the time, and also the location. For here example, the Batu Pahat Johor Mai, and the coordinates, the exact coordinates the person was smoking will be also being sent through the telegram. Moreover, admin users can also download the CSV file for the detection log, and also generate the PDF. If we click a generate PDF means it automatically downloads one file. Our option will be click, and we can download the PDF file, and we can see the smoking detection. The reason one is here. So this can be given for the smokers as an evidence in order them to find themselves. It was them, not a misclassification or misjudgment by the monitor or the system itself. And for the CSV logging detection, we can download it as well. We'll open an Excel file where it contains all the login activity when the user used. So it will stated the smoking detection Batu Pahat, where the person exactly log in and the exact coordinate.